Hi everyone, welcome back to the channel. In the last video of probability and statistics, I talked about the roadmap that we are going to follow in this playlist. And from this video onwards, we'll be starting the actual syllabus content. And in this video, I'll be starting with what is statistics, uh, population and samples, and then I'll talk about descriptive stats and inferential stats. Although obviously I cannot cover the whole descriptive and inferential stats in this video, so the later videos that will be coming in this playlist will talk about the topics of descriptive and inferential statistics in depth. But in this video, you will just get an overview of what is descriptive and inferential statistics along with some examples. So it will make you it will make easier for you to understand these two concepts. And as we go along, you will get a much better idea about these two topics. So let's start with what is statistics. So now we'll start with statistics. So talking about the definition, statistics is the science of collecting, analyzing, interpreting, and presenting data. And presenting data, right? So I'll give you one example. Let's say you do a survey, right? And the survey is from, let's say, 1,000 people, right? So this is how you collect the data. And then you let's say you just transfer that data into an Excel sheet, right? And transferring that data into Excel sheet is basically for the purpose of analyzing the data and interpreting the data. And then let's say after that you make the presentation for it, or you just kind of find some conclusion. That is basically presenting the data, right? So this is the steps that we have in statistics. And almost every machine learning problem that you do, or data analysis or EDA that we perform in machine learning and data analysis, it's almost the same steps. So this was statistics. And after that, we need to also understand one more thing. What is data, right? So it's a really easy definition, but still I would want to go, over this. So it's a collection of facts, numbers, words, or other useful information, right? So again, let's say you collect height of students in your class, and you get something like 180. All of these are in centimeters, by the way. 180, 178, 177, and let's say you have 160, 175, and so on. So basically this is data, right? You collect some data from either it can be in the form of facts, numbers, even text, or any other useful information. So okay, now we need to understand why this data matters so much, right? Why we are focusing so much on statistics and data. So I'll give you one example. Let's say you are a cafe owner, right? You own a cafe and you record data. How many customers um come to your cafe every day for 7 days. So for 1 week, you record this data, that how many number of customers you have every single day. So let's say that list turns out to be like 80, right? 75, uh, 90, 88, and let's say 77, and then again, let's say 115 and 145, right? So this is the data that you have from Monday to Sunday. Now, if you have this data and you do some kind of inference on it, or you do some modeling on this data, obviously with the help of machine learning, so then you can make predictions about your future customers. So let's say, as you can see through this data, that on Saturday and Sunday you have a lot more customers than the normal weekdays, right? So you can make inference about this. Okay, that on weekends I will have more customers, so I need to prepare more, food for them, or whatever you serve in the cafe. You need to have more, like you need to prepare yourself more as compared to the other days. So these kind of inferences can be made from data, and as business owners, or as stakeholders, these kind of outputs are really helpful in growing your business. So this is why it matters a lot in analytics or data science, that you should be able to make conclusions about the data. If you are really good in doing this, then it's really helpful for your like the purpose that you're trying to solve. Now let's talk about the two types of statistics we have, right? So types of statistics. In this, we have descriptive stats, and the second one is inferential stats, right? And now we'll be starting with descriptive stats, and later on, I'll be covering inferential stats as well in the video. But make sure you note one thing, that I won't be covering inferential stats in depth, because the syllabus is a lot. So I'll be covering individual topics in the later videos, and the same for descriptive stats. But for now, you will have a overview of what descriptive stats is and what is inferential stats, right? And starting with types of statistics, you need to understand one more concept, that is population versus sample, right? Okay, so what is population? So population is the entire group, the entire group you are interested in studying, and it is denoted by n, right? Similarly, what is sample? Okay, I'll give you one example of this. So let's say um, you want to find the average height in your city, right? So in this case, the population is all of the people living in your city, and this is denoted by n. And similarly, sample is it is a so it is a smaller data set that is the subset of the population, and it is denoted by n. So again, I'll take the same example. Let's say your population was all of the people living in your city, but your sample will be, let's say there are 10 different districts, or let's say 10 different um, societies in your city, and you pick, let's say, 5,000 people from each society. So in total, those 50,000 people will be your sample. And in this case, you will only be dealing with 50,000 people rather than all of the people living in your city. Let's say the total population was somewhere around, 600K, right? So instead of 600,000 people, you're now only dealing with 50,000 people, and it's a smaller data set that is the subset of the population. Now we'll be talking about descriptive statistics. So I hope you are clear with population in sample. So population is nothing but it's the whole group of people that you are interested in, and sample is just a subset of that population, nothing else, right? So now we'll talk descriptive statistics, right? So talking about the definition, it focuses on summarizing and describing the features in a data set, right? So let's say you have um, a list of ages, and you have, like, let's say 7, 9, 10, 12, 15, 17, 6, and so on, right? So this is a feature, this is a variable, right? And in this variable, when you try to find the mean, or you're trying to find the mode, or any other measure, that is basically, we are dealing with descriptive statistics. So you get to know the distribution of the data, you get an idea about the different summary statistics about that feature. So key components in descriptive stats are measures of central tendency, measures of central tendency, which includes mean, median, and mode, right? So these three measures come under central tendency. And similarly, we have measures of dispersion. And in measures of dispersion, we have variance, we have standard deviation, we have range, we have IQR, right? And we also have coefficient of variation, right? So these things come under measures of dispersion. There are a few other measures as well, but we'll be talking about them later on as well. And the third thing is distribution of distribution shapes, right? So let's say the data is skewed, right? There is skewness in the data, or we see any kind of kurtosis. Now, what is kurtosis? It's a measure of tailness in the data. Uh, so let's say we have a data something like this, right? And the data looks uh, something like this, right? So first of all, this data is skewed, and this is skewed towards the right side. And you see these heavy tails, right? Like, heavy tails mean that this area is slightly, more as compared to any other distribution. If we had a distribution like this, right? Then the second distribution that I made, that is less heavy as compared to the first one. So this, tailedness is basically related to kurtosis. We'll talk about it in the upcoming videos. But this distribution of shapes also come under descriptive statistics. Similarly, I have, visualization tools, right? I have visualization tools, right? Like histogram, bar chart, box plot, all these things, like pair plot, and you have like pie chart. So all these visualization tools as well, they all come under descriptive statistics. Now let's say we have um, I'll give you the same example again, the cafe one. Let's say you record the data of incoming customers for 7 days, right? Now the data turns out to be something like this: 80, 85, 82, 77, 79, 116, and let's say 130, right? So this is the data for the 7 days that you have. Now, if you want to calculate the mean, okay, so what is mean? Mean is um, sum of all the values in the data divided by number of values. In other words, if you want to write summation of 1 to n x of I divided by n, right? So you take the sum of all the values in the data and then you divide by the number of values you have. So in this case, I'll do the calculation quickly, and then I'll tell you what is the mean, right? So the mean turns out to be 92.7, right? And this means that on average, this means that on average, 92.7 customers came to your cafe each day, right? Now let's talk about median, right? So median is the middle number on a sorted list of data, on a sorted list of data, right? So again, let's say you have the same list over here. This, where you record the number of incoming customers each day for 7 days. Now, if you can see that this list is not in an ascending order, right? So to find the median, what you do is you first sort this list in ascending order, and then you find the middle value from this data, and that middle value is your median. So first I'll sort this list, and then I will try to find the mean from this. So this is my sorted list, right? I've sorted this in ascending order. Now, the first thing that you do is you count the number of values in this, right? So in this case, I have 7 values. So in case of odd number, like, if you have odd number of values, it's really simple to find the median. What you do is so the formula for median is n plus 1, sorry, n plus 1 divided by 2 term, right? And this is only for if you have odd number of values. So this is only for odd number of values. In case you have even number of values, the formula is slightly different, right? So if you want to find the median in this case, that turns out to be, so we have n is 7, like the total number of values. So 7 plus 1 is 8, 8 divided by 2 is 4, the fourth term in the data. So the fourth term is 82. So in this case, 82 is my median, right? And similarly, if you want to find the mode from this data, so mode is nothing but it is the most occurring value or category in the data, right? In this case, since we don't have any value which is like, the most repeated, all the values are just ones, so we don't have any mode. I had, um, but let's say I had a data like, the color of cars. So I had, I'll just write the short form. So I had red, blue, green, orange, right? Again, blue. And similarly, I have, let's say, another color, purple, right? So all of these things. Let's say one more color, which is red, right? So the thing is, now you can see that red is the most occurring category in this data. So if I talk about the mode, it is red or R, right? Because R is occurring three times, one, two, and three. If I talk about the second most occurring category, it's blue. It's one and only two times, right? Now you have to remember one thing, that in certain cases you may have more than one modes, right? So let's say if I have another data one with the same list, let's say red, blue, green, orange, blue, purple, red, and I have another blue. So it is completely fine if you have more than one modes. So in this case, my mode is red and blue. And this kind of data is basically called bimodal, right? In which we have two modes. And similarly, you can have data which has more than two modes as well. And that kind of data is called multimodal, right? So you can have either, so I'll write it over here. You can either have uh, zero modes, right? Mean, which means that you have no mode in the data. If you have one mode, that is like unimodal, right? As I showed you before. If you have two modes, that is called bimodal. And if you have more than two modes, that is called multimodal distribution, right? So this was for the modes, right? I think before going forward, I need to give you the formula for the median, which I forgot before. So median, if you want to find the median in case of even number of values, right? So the formula is n by 2 term plus n by 2 plus 1 term divided by 2, right? So let's say we have age column again, age list. And in this one, I have, let's say, 18, 20, 23, 27, let's say 28 and 30, right? So I have six values over here, six values, right? So if I just plug in the this n in the formula, so I get median is 6 by 2 is 3 plus 6 by 2 is 3 plus 1 is fourth term, right? This is the term, the nth term, right? Divided by 2. So the third term in this is 1, 2, 3 is 23 plus 27 divided by 2, which you get as 25. So if you want to find the median for this data, that is 25. And remember one thing, guys, sometimes the median will not be in the data, right? So in case of, odd number of values, if I go above, right? This 82, the median was present in the list, but that is not always the case. As you saw here, 25 is not available in the list. So sometimes the median might not be, available in your data. So this is something that you need to remember. Now we'll talk about, inferential statistics. So if I talk about the definition, inferential statistics, it allows us to make predictions, generalizations, or decisions about a larger population using sample data, right? So let's say I've already discussed what is sample and population before. So let's say if I have a sample, right? This is a sample and I have this data, right? And I want to make inference about the population, which obviously I don't have the data for all of this population. So using this data for the sample, I can make some conclusions, or predictions about this population data. Right? I'll give you one example to make it more easier for you to understand. But before that, we need to understand why do we need this, right? What is the need for inferential statistics? So why do we need it, right? The first thing is It's impossible for you to collect every piece of data, right? Why? Because look, I'll go back to the same example of, finding the average height of, every person, like finding the average height of people in your city. So let's say if you have 600,000 people living in your city, it's nearly impossible to go to each and everyone and ask about their age, their height, and then, find the mean of it, or, the median, whatever you are trying to find. So the thing is, this is why we need to then work with samples, because collecting every piece of information about that population is nearly impossible. The second thing is, we rely on samples sorry we rely on samples to estimate the population behavior. The same thing again, that if you have data for, let's say, 10,000 people, right, and you find the average height of these people, then you can try to make some conclusion about the population, that okay, my actual population, like all of the people living in my city, they might be, somewhere around the same height. So this is how you make inferences about the population. And the third thing is, it's basically samples you will study later on, like central limit distribution. All of inferential statistics is based on this. It is the core of ML, right? Core of machine learning, because ultimately model training is equals to inference. Why? If you haven't studied machine learning, and when you do it, you will understand that when you use the dot predict method, on any machine learning algorithm, that is basically you're passing in some test data to get some predictions about the unseen data, or the data, like about the population that you don't have as of now. So that this predict method basically gives you that inference about the data that you don't have, right? So the data that you don't have is the population data, and the data that you pass in this, let's say, X test, that is basically the sample data, or just the very limited data that you're available, that you have with you. So this is again a very important part of machine learning as well, that not every time you will be given all the data, or it's not easy to work with a huge amount of information. So that is why we use samples. And the key topics in inferential stats are population and sample, which I've already discussed before. The second is sampling methods, which will be covered in the upcoming videos. The third one is estimation. Estimation is basically point estimation plus confidence intervals. And the fourth thing is hypothesis testing, right? So let's say we have t-tests, chi-square, ANOVA, all of these tests. Hypothesis testing is also a part of inferential statistics. So, guys, this was about the basics of statistics, descriptive statistics, and inferential statistics. And we also discussed about population and sample. And in the upcoming videos, we'll talk about descriptive stats in depth. Everything will be, discussed in detail. Don't worry about it. And similarly for the inferential statistics. And as going in the playlist, we'll first discuss about descriptive statistics, and later on, after that, once it's finished, then we will move on to inferential statistics. I hope you like the video, and if you do, please consider subscribing to the channel, and I hope to see you in the next video. Take care. Bye.